Hi, and welcome back to Gaming for Tokens. I'm Marshall, and in this episode, we're going to be doing the deep dive into what I've done in the last video with the AI scripts that we were looking at last time that I had kind of laid the foundation work for. A lot has changed, but I'll hopefully do a decent job of explaining what changed, and this may be divided into two videos. I want to keep it, if I can do it in 45 minutes, I'll keep it as one. If it extends to an hour, I'll do it in two half-hour videos just to keep it kind of concise. We'll see where I'm at a half hour, and I'll make the call then. So the first thing you're going to notice is that there's a lot more information over here on our ambient AI scripts that we were working in before, like a lot more information. And you notice that a good chunk of that information is under the perception info, and some of it's under the attack info. The rest of this stuff is all kind of sort of what was already there. Some of it's not, some of it's new rather. But the first thing I want to do is I want to go over the AI requirements list that we came up with before, and talk about what I have and haven't done and what I'm doing differently and things like that. So our wander state with the speed, min-max, radius, wait times, and health gain. We kind of had this before where we had the wander speed and radius. Did we? I believe so. Yeah, I think we did. Because I'm just doing attacking and stuff this time. Right. Because all they were doing is wandering. Right. Okay, so I added state changes and stuff in. I'm remembering now. So the wander state with the min-max radius and all that stuff was in last time. I did include health gain because I got the attacking and damaging systems and all that stuff in. So health gain is a thing. It happens not only in wander state but also in the flee state. Because I felt like anytime, or no, it doesn't happen in the flee state. It only happens in the wander state and investigate state, which is another state that we didn't actually put in here. The reason why I did that was because I didn't want the health gain to happen when the person was in combat, if that makes sense at all. So quote unquote combat, it's spheres, so they just get close to each other and deal damage to each other. But I didn't want health gain to happen when there was a potential that you would be losing health. So when you're safe, you gain health. When you're not, you don't, if that makes sense. I got the cone of vision in, so they do see enemies, and they can target a single enemy at a time. They can see multiple enemies, and they always target the ones closest to them. And I will be explaining all of this in the code in the ambient AI script right here that you see hiding. I will get there. It's just I want to go over these first. Factions and alignments, I kind of had those in last time as well, but now I'm using them, which is important. The big deal is using these to drive who the enemy sees as enemies, or who the AI sees as enemies and allies, which they do see their allies as well, but it's kind of a lesser sight, I guess. An attack state with a chase speed. This is one of the times that I kind of deviated from this original design a little bit. There is an attack state, but it is also the flee or the pursue state. So it's kind of a bundled thing. They chase down the enemy and attack. That's their state. And they don't have a chase speed. They have that's their normal movement speed. Well, I moved the chase speed concept into the flee state. So instead I have a flee speed that is higher than their normal attack, or their normal speed. The theory being that they can run away faster than they want to attack somebody, so they're more cowardly than they are aggressive. And I kind of like that idea because it helps put leverage on the health gain, which happens when they get safe. So the idea is that they want to flee, and then they want to gain health, and they want to come back. Which makes, I think, it makes the AI a lot more compelling and interesting to script and to design. I think, at least. Maybe I'm crazy, but that's my opinion. I damage and health. I kind of talked about that. I have all that stuff in. I do have I have the attacks and the attack rate. There's only an attack, so attack is more. Well, that's not true. They do a random amount of damage, so I guess that's different attacks. I don't know, whatever. But they do have a rate of attack. So all of this stuff is in, minus the chase speed being in a different place. I did have all of this. I have all of this in now. I guess the next big thing to do is to hit play on this thing and see what happens. and I'll kind of explain what happens as it's happening. Just so you guys know, these two guys right here, as you can see here, are faction A, and these two guys here are... Whoa, okay. Calm down. These two guys are faction B. So faction A over here and faction B over here. So when I hit start, they should start moving around. So you'll see immediately, whoa, okay, stuff's happening. You'll see immediately these big green triangles coming off of every one of them. And I'm actually going to start that over again so that there's not immediately conflict. So you see these big green triangles. These are their cones of vision, and we can toggle this on and off over here. God, I hate that. Whenever you double click on something in the hierarchy, if you do it on accident, so like if I click here and then here, oh no, if you accidentally double click on something, it'll zoom in on the object. It's really annoying. Anyway, so if I open this up and I turn off the debug viz on the perception info, and I click one frame over, which by the way, that's what this does. This is a step frame, so it'll calculate the next frame, and it'll run all your update functions once. So this is really, really handy for debug, this little button up here, this little next button. Anyway, so I can turn off those green triangles with the debug viz perception off. And I'll get to what that is and why that happens and how I did this in just a minute, because I don't think I've talked much about debug stuff in the series yet, and that's kind of a travesty. Debug stuff is so handy. It's so cool. Because you get stuff like this, where we can actually see the cone of vision. We can see how far this AI can effectively see. So that's what this is. The red lines that you're seeing down here are the pathing. That's what that is. That's just all the arrows and stuff like that are all part of the navigation and pathfinding stuff. And we will probably see here in a second. Oh, see, these guys are a different alignment and they can't see each other. I like it. Okay, so there. What this is right now is this guy, this guy right here, the alignment A guy. I'll call this guy Guy A and Guy B. Guy A is within Guy B's cone of vision, but Guy B is not within cone A's cone of vision. So Guy B can see Guy A, and he's going to run up and punch him. But what we're going to see here is that there's a minimum distance on the perception, and he's going to turn around before he gets there because he's going to notice him because he's going to be too close. Right there. Oh, no? Okay, well, he got hit, so I guess that's a thing. So now what we're seeing here is a giant mess, I guess, of green lines. So these two guys are fighting right now. And we're going to see that down here on their base. They have a current health. See how he's at 96 health? They start off at 100. That's what their base health is up here. And normally this isn't going to be visible. I have this visible for debug purposes and for example purposes. But so this means that they're already dealing damage to each other, and we'll see that go down as time goes on. See? And now this guy's going to start losing health twice as fast because he has two guys on him. His buddy's over here just wandering around. You can see that on the bottom screen. And meanwhile, he's getting his butt kicked by two AI at the same time. And normally there would every time somebody takes damage or deals damage, there would be an effect, right? There would be like a whoosh, like sweeping attack effect that looks very, very motiony. And this guy would have like a blood effect come off of him or whatever, or a particle effect or like whatever you wanted. And I considered doing that, and I should have, but I dropped the ball on that. It's actually really easy to do, and maybe I can do that during the video. That would probably kick us into the two-part video, but it might be worth it to do that. It could be fun. Anyway, so that's what's happening now is these two guys right here, this guy and this guy, are both of alignment A, and they're beating up this alignment B guy. And eventually that alignment B guy is going to get fed up, and he's going to run away. Oh, no, this guy ran away first. Oh, interesting. So he ran away. And now this guy... Oh, something weird's going on with it. I should probably mention that these scripts are not at all finished. This is a good time to mention that. There are bugs every now and then, and that's one of them. Sometimes whenever three of them are in a fight, and then two of them are fighting, and then a third one walks up, if one of those original two flee, like that happened there, sometimes they get messed up. And this is something that you're going to start seeing with AI systems and things. Once you get into state changes and systems, you'll notice that you're going to have to start debugging your code in much more intense ways, and you kind of get a respect for the QA side of things because I don't know what's causing that, and I'm probably not going to fix it, to be perfectly honest. Just because, I mean, everything else works fine, and this is an example. So what we're seeing here is this guy is running away, and he's running into danger? No, okay. This is another problem that I'm running into. He keeps going into the investigate state, and then the investigate state kicks him closer to the enemy, so he freaks out and flees. So what I'm going to do is I'm going to grab him and I'm going to throw him over here. That's actually probably easy to fix, and I might fix that. Same thing is happening. Get over here. So the investigate state is really interesting. I'll talk about that in a minute. But so now this guy right here is fleeing. You'll see that down here. He's going between investigate and flee because he gets out of the range of things. And this guy here is chasing him. And now this guy, because he regained... let me see here. So... yeah. What's happening is this guy right here is being aggressive and chasing this guy down to beat him up because he only has 50 health left, and that's our flee number. And this guy has 52 health, so he's like 2 points above the flee number. And this guy down here is now investigating what the hell was happening. And so he's going to look around a little bit, and he's going to stay there. And now he's in the wander state, which means he's going to start regaining health every 1 second. He should be regaining health. It doesn't look like he is. That might be broken. Oh, it looks broken. Oh, that's so sad. No, wait, maybe they only gain up to 50. I'll have to look at how that works again. Anyway, now this guy over here is still fleeing from this guy. Meanwhile, this guy's just kind of over here. He's stuck in investigation. It's probably a bug on my part. Let's kick him back into wander. See what happens. And typically speaking, what'll happen is this guy, I mean, the guy that's fleeing here will eventually this will catch up to him, and he'll kill him. And when they die, they disappear. So again, this is kind of really stupid and strange and simple AI, but it's interesting. I mean, there are things happening, right? And if we select all of them and maybe we increase their flee distance to 9999999, like that, so they'll flee forever until they're away from the enemy, and giving them a chance to kind of recoup some health, probably, I hope. And if I do end up spending some more time on this, I'll have all these bugs fixed and everything. But let's instigate some fights here. Whoa, I didn't want to move all of them. Let's instigate A over here, and they should see each other now. And yeah, so let's see what happens when they decide to fight. So right now they're fighting. You can usually tell because they're not moving and they're locked in front of each other. They look directly at each other when they fight, so you can usually see this big X, and in the middle of the X are usually two AI fighting. Now, what's interesting here is that this guy is trying to flee, but he can't move. So if I moved him over here, he would be able to run away. It doesn't look like he wants to. Okay, there. Well, sort of. There he goes. Anyway, he's gonna die. So you get to see what happens when they die. Oh, I think I know what's happening. Oh, weird. Okay. Something really strange is happening with the, yeah, I finally got a bug on that. Anyway, what was happening there is I realized that the flee distance, what he's doing is he's trying to find a like a nav mesh way the hell out here, and he can't. So we probably want to pull that into like 50. That's a mistake on my end and something else I would have to fix. You can tell I haven't done a whole lot of testing on this. I just got this working before the video recording started, so to the extent that it's in now. I wanted to record a video and get it up before I got too complicated and messy with this, because like I said in the last video, you can keep layering and layering and layering and layering complexity on AI scripting, and it'll never be as good as you want it to be. And this is kind of a testament to that. I have a lot of stuff in the script already, and it's still broken. It's still not doing exactly what I want. So let's crawl up inside this code and wear it like a coat. What we have, I'm going to go ahead and skip these classes for now. Well, I mean, for the moment. And I'm going to start in on our main class here. And you'll see that I have a crap load of variables, right? Just kind of like what we saw over here. I have a debug bool, which you'll see in a lot of my code. I like to do this. Put a big all caps debug at the top of a script, so you can check on and off a debug output for the object. So if I turn on the debug output on Path Buddy A, we'll see that it'll start to spew a crap load of stuff out. And this is really handy for a number of reasons. First off, it tells me what is happening on initialization. It tells anything that I output to the debug, I can run this check to say, hey, I want to be able to toggle a bunch of debug spew on a specific AI, right? So on this guy, I can see how many targets he gathered. He found 1 ally, 2 enemies. He has a new wander distance. He is targeting Path Buddy C because he has a line of sight to him, but he's not within his cone vision, because we can see that by the angle being 116 instead of 30, or 60, which is half of our vision angle. So we have all this information that we're in Path Buddy D, and he can't see him because it's 100, which is more than 60. And then the distance is also 26, which is not within our vision distance. So we know all these things, and we can look, and if he is seeing him, we can kind of compare to the variables that we have here and say, oh, that's weird. Why is he seeing him when clearly he shouldn't be? And then all of the stuff afterwards is all because I'm collapsing things like I shouldn't be. So we'll see that it's just constantly running this, I can see you, here's the information on it. The reason why I have this is because of this next button. I can go boop, and now I see the angle and distance this frame from the 2 guys that he can theoretically see. Because I believe he can run a line of sight to this guy somehow, and I think he can run a line of sight to that guy somehow. And if he can't, he's checking to see if he can. I don't remember exactly there, but either way, that information is really handy for being able to, he can see this guy, and why can he when he shouldn't be able to, is kind of the idea. Anyway, kind of a big tangent on the debug bool, but I like to put that in because I like to be able to toggle debug information on a specific instance of an object. So you'll see this a lot in my scripts, and the reason why it's all caps is because there is a debug that is a cap with normal, or I guess a camel case debug. So I use all caps to signify that this is mine, and it also kind of sticks out up top, so you can, typically speaking, if you're not used to seeing my scripts, you can go, oh weird, there's a checkbox up at the top that's unchecked that has debug. It'll spew a bunch of crap out. And the reason why I have it as a toggle on each object is so that, because that was a lot of stuff to come out of that, even for a single frame. That was kind of a lot of information. And there would be more if there were more AI, right? If there were 50 AI on the screen, then it would just print out that angle and distance for every AI. So that would be over 100 lines. So it'd be nice if I didn't get that for every single AI in the scene. If I just got it for the one that I wanted, Anyway. So we have our alignment info, which is pretty much exactly what it was before. I didn't actually get rid of it. I don't know why I didn't. I think it was just because I was already making all these other classes that I decided, hey, I might as well keep it. We have our perception info, which is this beautiful class here. The stuff that's in here is the debug viz. That's the it's kind of like the debug checkbox, but specifically for the vision stuff. So if I were to run this and pause it, and I were to open up okay, it's already open. If I uncheck debug viz and run the next frame, it'll turn off his cone of vision. It'll also turn off all of the lines that he draws to enemies for when he can see them and when he can't. So that's kind of what that does. I have a line of sight mask. You may have noticed that I also have a layer mask for the environment mask down here. This is for navigation. This is for sight. There should be a difference between those, because say you have a glass wall, you don't want to be able to navigate through that black wall that glass wall necessarily, but you may want to be able to see through it. So that's kind of the distinction here. In this particular instance, it's, it's not really applicable. But I think in the environment mask I checked AI as a layer, because all these guys are on they're tagged with AI, and they have the AI layer, as you can see up here. I think on the environment mask I chose AI, even though the AI don't have colliders, so it's kind of ridiculous, but it's a good distinction to make. And like I said in the last video, you should always use your best practices, and that's kind of a best practice to get used to, is you should keep your vision separate from your navigation if you can, mostly because you can see through things that you can't necessarily move through. How far can we see? How far do we want to be able to see regardless of angle? It's kind of a confusing thing. The idea here being that if an AI is within this distance, the default is 4, but I think I bumped it to 8. Yeah, so I doubled it. If an AI is within 8 units of another AI, in theory, they should automatically detect them and turn around to fight them. I don't know if that's necessarily true with the way the AI are functioning right now, and I don't know why. The vision angle is what is the angle of vision that we can see on... Okay, that's the cone of vision that I was talking about before, right? That's the angle of the cone. So what I'm going to do here is I'm going to do a thing that will break this AI, for an example. So I turned off all the other AI, and I have just him, and I'm going to tinker with his vision angle, and you'll see here that this will change, right? So as we get smaller, our cone gets smaller, or more acute rather, and then as we get larger, our cone gets more obtuse. So the angle in which we can see gets larger or smaller. All right. Turn all this stuff back on before I forget and get confused. So that's what the cone of vision does. The current target is an ambient AI. I don't know that I've ever done anything like this before in these videos, but basically you can set a class as a variable, and you can assign that class a thing, because again, everything is an object. So, well, yeah, everything is an object. So your ambient AI is an object you can store, kind of like a game object, but it's your own custom object. It's your own custom monobehavior object. Well, in this particular case, it's a monobehavior object, but kind of like what I'm doing down here with the public alignment info, yada yada. I'm doing that up here too. And our current target is basically going to be, who are we currently looking at that we want to fight? Who are we going to chase down? Or who are we going to run from? Who are we targeting at the moment? Last known is the last known position of our current target. And sometimes, if you can see the current target, that's going to be the same. If the current target is null, or you can't see him, then this is going to be the last place that you did see him. And this is important for the investigation stuff, right? You want to be able to go to where you last saw your target and see if you can. For instance, if there's an AI up here and this guy saw him, and then this AI decided to go, ooh, I'm going to go down here. This guy doesn't go, oh, I don't know where he went. He's going to go, well, let's go where we last saw him, and then chase him down, right? So that's kind of what that is simulating. It doesn't do it very well, but I mean, it gets halfway there. Shows the last known position. The investigate time is how long will they investigate something before giving up, and that is after they've already arrived at the last known position, within the investigate distance. So actually, this probably needs to be reordered a little bit. Last known, boop, like that. That's a better organization for it. So the last known position is where they last saw the person. The investigate distance is how close to this last known position does the AI have to be in order to assume that they are there. They've arrived at that position. And you saw that I just changed that from 4 to 2. I don't like it being very big. I like the radius on these being rather tight. The idea is that with these next two things you'll see here, the idea is that the AI will arrive within 2 units of this location and then start to look around. It'll start to actually turn its body. The whole idea with that is that if this guy goes up here and is looking this way still, he won't see him, and it'll seem rather unintelligent if this AI, quote unquote, saw the other AI go up here and then go down this way, right? In theory, you would assume the AI would go here and then look in the direction that he saw the AI go, not stand here and look off into the space in the same direction he used to approach the destination. That would be weird, right? And that's kind of the uncanny valley thing that I was talking about before, where this AI walks up here and looks off this direction like, I don't know what's happening, instead of actually doing the investigative work that any of us would do naturally, right? Where it kind of maybe looks around a little bit to see where over here that guy went to. Now, because of the way that the AI is set up and because it's simple in nature, and I'm not an AI scripter, right? He would go up here and he would look in a random direction. So he might look back at where he came going, I don't know where he went. And I just kind of have accepted that. I don't want to make it ungodly complicated because I have to explain what I'm doing, and I wanted to do it in a timely fashion. But anyway, so that's kind of what the investigate time does, is how long does he stay at that location and look around before he decides, I don't know, he's gone, and just walks away. And in code sense, he goes up here for that long and then changes state back to wander from investigate, which may or may not be working at the moment. The look around change is how much time in between picking a new direction to look in. And then look around speed is how fast he turns to look in that direction. And this actually needs to be a lot lower by default. Alright. So that's the AI perception info, which is what this one here is here. So we're 3 down the list. Perfect. So again, the environment mask is navigation. The wander disk, min, and max. You kind of know what those do. I kind of talked about those in the last video. Destination wait times. Again, you know what those do, I believe. And then our behavior states, which is an enumerator, which I talked about in the last video as well. We have wander, investigate, attack, and flee. So that means our default is going to be to wander. We're going to wander around the space, and we're going to we're going to live our life, I guess, is what the AI is going to think as it's quote unquote think as it's as it's wandering around the space. It's just going to pick locations and go to them, and that's all it's doing. And then once it sees something and that something disappears, maybe it goes into investigate, and then maybe when it goes to that spot and it looks around and it sees a target, it goes to attack. And attack is also pursue, which is I think I mentioned that. Anyway, attack and pursue are the same thing. So the attack state is I am going to chase down somebody and attack him. The last state, flee, is I've taken too much damage, I need to get the hell out of here. So it runs away. And that happens based on this health flee percentage. When the current health, which is going to be down here, which I'll get to in a second, when the current health is below this percentage of the base health, so this is kind of a segue into this is kind of how all these things work together. So when in this particular case, 25% of base health is 25, right? Because it's 100, and when our current health right here is below 25, we're going to go into flee, and that's all this does. So this is our states. Our base health, what I just talked about, this is the health that we start at. Our health flee percentage is the percentage that we run at. The flee distance is how far away we're going to run from our enemy before we stop running. This is dangerous. So, confession time, I tried recording this video and then something happened and I had to restart again. So I don't know if I showed this or not, but in one of the recordings, and I think it was this recording, I increased that to really, really high, and it was choosing a value way over here, and it was trying to find nav mesh there, and it was breaking. So I need to do that in a better way. I need to do my flee distance in a better way. Because what it's doing is it's saying, draw a line from you to the target and then go the opposite direction by this much. It's not a good way to do it, I don't think. I just need to do a distance check and then tell my AI to find a destination in a different location, in the opposite direction. So I need to just tell my AI to go forward away from the enemy instead. But we'll get there. Flee speed. How fast do you move when you're running away? The attack info, the new attack info. Our attack info is up here. It's another class. And there's attack distance. This is the distance from me to my enemy for when I attack, when I can attack my opponent. The attack cooldown is how much time there is between attacks. The damage min, damage max, kind of self-explanatory. Maximum amount of damage I can deal, minimum amount of damage I can deal. And then the last attack time is this kind of gets complicated, but it's the timestamp between. So this gets modified when I make an attack. This gets set to the time stamp that I attacked in, and I can then, when I go to attack next time, I can check this time to see if the difference between those is greater than my cooldown, so that I can see if I can attack again. I did this way, so I didn't have to keep track of a timer. I didn't have to iterate and update a timer. That's the main reason I did that. That's the attack info. The regen rate is how many seconds before I gain a point of health. So in this particular case, every 1 second I'll gain 1 point of health. So after 100 seconds, I will fill my health from 0 to 100, which won't ever happen because if you're at 0, you're dead, right? So in 50 seconds, you'll fill back up from 50 to 100. Regen timer, the timer that we're using to regain health. Look destination is going to be our angle that we're going to turn to when we're investigating. Because again, so the way that I usually write code is all of these are in a very, very ordered, logical progression, I hope, usually. So like health flee percentage is right next to flee distance, all the flee stuff is together, all the health stuff is together, yada yada. Well, I guess the regen rate and base health could be. Actually, let's change that, yeah. There we go. So those are together. Things that are alike are together, but down here this is a crapshoot. Like all of my non-public variables are just a mess, and that's just the way that I do things. I just kind of stack them on top. It's probably bad, but it's because in my experience trying to order these was just a losing battle for me, and it was always a big waste of time. So sorry about that, but I'm gonna kind of go through all these really quickly and explain how I'm using them. Regen timer again is the timer that we're using to track when we should gain health back from the regen rate. The look destination is the angle in which we are going to be moving towards when we're in investigate mode and we're switching directions. It's kind of a bad explanation if you don't understand how that works, but we'll get there and you'll see how it's used. Our investigate timer is how long we've been investigating a location. Again, if we investigate it longer than, I believe, 2 seconds, yep, then we give up and walk away. Look around timer is how, again, having to do with this look around change thing, how long we've been looking at our current place and we need to move to another one. The base speed is a setter, or well, it's more of a storage. It's like a reference value, I guess, is what I'm using it for. I take the base speed of the nav mesh agent, which is going to be where is it here? Oh, speed right there. Right, because this is it. That because I screwed with it. There we go. So it's 3.5 by default on all these guys, because that's, I think, whatever the default is on the nav mesh agent. But on start, you'll see right here, I set it to that speed. Because I have the flee speed up here, I know that I'm going to be fluctuating between the base speed and the flee speed, and I need to remember what that base speed is so I can reference it later on to set it back. It's kind of just a way to go back and forth between them. I need to have both of these variable values referenced so that I can use this as a fluctuating field, and these are static fields, I guess. My current health, which is how much health I currently have as the AI. My search radius, which is not actually how it sounds. This is actually what's called, I guess you'd call it legacy from the last video. This is what I was using to, this is the radius that the nav mesh checks will search for nav mesh. So they'll search for 2 units, within 2 units of the point that I try to sample on the nav mesh. They'll search within 2 units of that. The nav mesh agent is our nav mesh agent, our enum agent from last video. Our current wait time and our desk wait timer are, again, for the wanderer states. I think I talked about those in the last video. How long until we choose a new destination while we're at our current, and how long have we been at our current destination, I guess. These are our lists of all of our allies and all of our enemies. So this is everybody, all the AI objects in the scene that are also of the same alignment, all of the allies in the scene that are of differing alignment. And the way that I have this check set up, and this is probably going to be the first thing because it's at a half hour and I'm not even done explaining the variables yet. I will probably end up making this a two-parter video and stop after I explain the variables, which is a terrible place to stop. But I'm going to go ahead and do that. But anyway, the way this check is set up is neither of these lists will ever include myself. So this AI will never be in its own allies list. Only its other friends will be. So in this example here, we have 2A and 2B. This guy happens to be in alignment A. So this is only, the allies list is only going to be 1 long. It's going to include that guy right there. And the enemies list is going to be 2 long, and it's going to include these 2 guys over here. And that's just how this is going to set up. This is how this is going to work. And I know that because I've done this 1,000 times, and if I hit play and pause it, you'll see here that the allies contains 1 guy, and it is our friend, ally B, or pathing buddy B. And the other one includes C and D, our other two guys. So we know that that's the case. We know that this is going to be the way that works. And yeah, so that's the description of everything, all of the variables that I've added. And in the next video, I'm going to be talking about all of these, all of the stuff that I'm doing in here to gather those lists and parse what state I should be in and how to do state changes and all that stuff. It's going to be a lot to wrap your head around, and I am going to be talking a lot about math in the next video. I hate math. I hate talking about math. I hate doing math, but you got to do it. It's just a thing that's going to happen from time to time, and you got to be comfortable with it, I guess. So there's going to be some talk of trigonometry, some talk of what radians are, and how do you get angles, and how do you compare angles between 2 objects, like based off of the forward vector of an object. How do we parse the angle? How do we get the angle of the forward object? Whoa, I just can't talk today, I guess. How do we get the angle between the forward vector of an object and a vector pointing in the direction of our targeted enemy? And how do we compare that to our cone of vision, for example? That sort of thing. It's going to kind of gnarly, and it's going to get kind of heavy. But I'm hoping you guys are good to go with this. Again, this is all a request from someone, so blame them, not me. But no, it should be good. It should be good. I'm going to talk about all that stuff in the next video. So for now, thanks for watching, and bye-bye.